Today, our topic bias compensation techniques. So, previous classes we talked about different biasing techniques and stabilization techniques. So, in biasing techniques, we've seen three types. One is fixed bias technique, and the second one is collector to base bias technique, and third one is voltage divider bias or potential divider bias technique. So in three cases, we've seen stabilization techniques along with. So in stabilization, the operating point we have to maintain constant. So in fixed bias, the stability factor is very poor compared to collector to base bias. Similarly, in voltage divider bias, the stability factor is very high. That means stabilization is it's nearer to 1. If stability factor range is 0 to 1. If stability factor is nearer to 1 means stabilization is more. So these things we seen. So today we will see bias compensation techniques. What do you mean by bias? So in bias compensation techniques, the biasing circuit provides stability of operating point in case of variations in the transistor parameters such as IC0, VBE and beta. So IC0 means it is a reverse saturation current. VBE means base emitter voltage and beta means amplification factor. Okay, that is called biasing. What is stabilization technique? The stabilization technique refers to the use of resistive biasing circuits which permits IB to vary. So as to keep collector current or output current, we have to maintain constant. That is called stabilization technique. So today we will see the compensation techniques. So compensation techniques refer to the use of temperature sensitive devices such as diodes, thermistors, sensistors and so on to compensate for the variations in the currents. Okay, so these are the compensation techniques. So biasing circuits provides stability of operating point in case of variations in the transistor parameters IC0, VBE and beta. The stabilization techniques refers to the use of resistive biasing circuits which permits IB to vary so as to keep IC relatively constant. Here stabilization factor S is equal to 1 plus beta by 1 minus beta into dou IB by dou IC. So you see that formula S is equal to 1 plus beta by 1 minus beta into dou IB by dou IC. Okay. So in compensation techniques, we will see one by one. So three types are there. One is diode compensation technique. Second one is thermistor compensation technique. And third one is sensistor compensation technique. So this is the diode compensation technique. So you can observe this circuit. So same circuit visibly you will see here. So this circuit, first analyze this circuit. So it is a transistor amplifier circuit which is having one collector resistance. So this is the collector resistance. So this is the RB means base resistance and a diode. Diode is connected across. This one is the base and emitter. So this one is the diode. Diode is connected across base and emitter terminal. This is the I0 is the reverse saturation current. So reverse saturation current exists when diode is operating at reverse bias. Okay. So this is the description of circuit. Now we will see when temperature is increases, what happen, how we will compensate the uh, IC naught or VBE or beta. Okay. So here you can remember transistor and diode both are same manufacturing unit, that is same material, both are same material. Okay. See, when temperature is increases, so here see, so the reverse saturation current of the diode will increase with the temperature. At the same rate, the transistor collector saturation current IC naught is also increases. See, when temperature increases, reverse saturation current of transistor IC naught increases. If IC naught increases, what happens? Heat will be increases. If heat is increases means transistor may burn or damage. So to compensate that increased IC naught, we will connect a diode across base and emitter terminal. Okay. So here IB base current is equal to I minus I naught. So base current, this one is the base current. IB is equal to I minus total current minus I naught, diode reverse saturation current. We know that IC is equal to beta IB. IC is equal to beta IB. So here beta IB. IB means I minus I naught. Okay. So as long as temperature is constant, diode act as a resistor. If temperature is constant, diode is act as a resistor, just resistor. As temperature increases, IC naught of transistor increases. So to compensate the IC naught, the base current should be decreased. If temperature increases, IC naught of transistor is increases. So to compensate this IC naught, base current IB should be decreased. Okay. So this increase of temperature not only increases IC naught here, but also increases I naught of a diode. Okay, if I naught is increases, thereby decreasing the base current IB. Okay, if I naught is increases, so total current minus I naught, so IB will decrease. So this is the required action to keep the IC is constant. So this is called diode compensation. So I repeat, listen carefully. So this technique is we have to maintain the operating point is constant due to temperature variations such as VBE, IC0 and beta. So this is the diode compensation circuit. So as long as temperature is constant, this diode across base and emitter region is act as a resistor. If temperature is increases, so first step, if temperature is increases, IC0 of a transistor increases. If IC0 is increases, at the same time I0 is also increases. I0 of a diode. If I0 is increases, IB means base current will decrease. So this is our required action. If base current IB is decreases, IC0 is decreases. So this is a cycle. See, first I will wrote here. First, IC0. If temperature is increases, IC0 increases. At the same time, I0 is also increases. Then the base VBE means base emitter voltage is decreases. VBE is decreases. If VB is decreases means IB. IB is decreases. If IB decreases means what happen if IB? Total IB is decreased. Here you will see. If IB is decreases means IC also decreases. If IB is decreases means IC also decreases because IC is equal to beta into I minus I naught. Okay. So if temperature, even though temperature increases, we will reduce or compensate how much increase, that much we will decrease based on base current variations. So this is called diode compensation technique. Okay, this is called diode compensation technique. Next we will see thermistor. So thermistor is a temperature sensitive device. It has a negative temperature coefficient. So if temperature, if resistance of thermistor is increases, when temperature is decreases, and it decreases when temperature is increases because it is a negative temperature coefficient. See, as increase in the temperature, we will decrease the base voltage VBE, reducing IB and IC. So I will clearly explain in this figure. So this is the thermistor bias compensation technique. First, you will analyze this circuit. So it is an amplifier circuit, so which consists of thermistor. This is the thermistor. RT is the thermistor. It is a negative temperature coefficient. This one is R1, R2 voltage dividers, and this one is the collector resistance. This one is the collector resistance. This one is the emitter resistance. Okay. So this is the description of thermistor bias compensation. So this thermistor is connected across R2. That means parallelly we are connecting R2 and RE thermistor. So the resistance of thermistor. So what is the main characteristic of thermistor means it is a negative temperature coefficient. So negative temperature coefficient means if temperature is increases, resistance decreases. If temperature is decreases, resistance is increases. That is the meaning of negative temperature coefficient. So the resistance of thermistor, so this one, the resistance of thermistor is decreases exponentially with increase of temperature. An increase in temperature will decrease the base voltage. Why? If temperature is increases, so this resistance is decreases. This resistance is parallel to R2. So whole here VBE also. If resistance is decreases means VBE also decreases. If VBE decreases means IB decreases. Okay, that is the meaning here. IB decreases. So if IB decreases means IC is also decreases. Same previous what we talked in previous circuit diode compensation. Here also same. I will repeat. Now I repeat. First, if temperature is increases, what happens? First step. If temperature is increases, IC is increases. IC is increases. If IC is increases means our Q point is VCE comma IC. So this is the Q point we have to maintain. It is the constant. If IC increases means Q point may vary. We have to maintain that Q point at a stable. So if temperature is increases means IC increases. We have to reduce this IC value. So for that reason we are connecting a thermistor across R2 and RE. So if temperature is increases, what happens? Thermistor resistance decreases because it is a negative temperature coefficient. Temperature is increases means resistance is decreased. So resistance is decreased means here thermistor resistance RT is decreases. If RT is decreases means VBE. VBE is decrease. If VBE is decrease means IB is decrease. If IB is decrease means IC also decrease. So how much percent IC increases, that much percent we will compensate by using thermistor. Okay, this is called thermistor bias compensation. Okay, next we will see other technique. What is other technique? Sensistor. What do you mean by sensistor? Sensistor is a heavily doped semiconductor that has positive temperature coefficient. The resistance of a sensistor increases with increase in the temperature and decreases with decrease in the temperature. It is exact opposite to the thermistor. Okay, we will see in detail. So this is the sensistor bias compensation. Now we will analyze the circuit. So it is an amplifier circuit. This one is the transistor. So this one is RC, means collector resistance, emitter resistance. This is voltage dividing R1 resistance, R2 resistance. So this is called RS. RS means sensistor. So that means sensistor is connected across R1 or RC in between. So the sensistor is connected across R1 or RC. In between that we are connecting a sensistor. So sensistor is a positive temperature coefficient. Sensistor is a positive temperature coefficient. Okay. So that means if temperature is increases, resistance is increases. If temperature is decreases, resistance is decreases. That is the meaning of positive temperature coefficient. So we will see if temperature is increases. So if temperature is increases, what happens? If temperature is increases, IC here IC naught. IC naught increases. If IC naught is increases, we have to reduce this IC naught by using the sensistor device. So if temperature is increases, the equivalent resistance of a parallel combination of R1 and RS also increases because it is a positive temperature coefficient. Temperature is increases, resistance is increases. If resistance is increases, this whole combination is also resistance is increases. Hence, the base voltage VPE decreases because VCC minus this voltage, VCC minus this voltage, so VBE voltage is decreases. So if VBE is decreases means IBE is decreases and IC is decrease. So this reduced IC compensate for the increased IC caused by the increase in IC naught, comma VBE and beta due to temperature rise. So this is called sensistor bias compensation. Okay, I repeat. So it is a sensistor bias compensation circuit if temperature is increased. First step, if temperature is increased, what happens? It is a positive temperature coefficient sensistor. If temperature is increased means resistance is also increased. So these RS and R1 are parallel. So here whole resistance is increased. If whole resistance is increased means here VBE voltage is decreased. If VBE voltage is decreased means IB base current is decreased. If base current is decreased means IC is decreased. How much IC naught is increased before, that much we will decrease by using sensistor device. So that is called sensistor biasing. So even though temperature is increases, we have to reduce the IC so that we have to maintain the Q point VCE comma IC. So how much percent IC is increased, that much percent we will reduce at the output side by using sensistor device, so that this amplifier circuit works properly and we will get good output and a constant output in amplifier circuit. These are called compensation techniques in transistors. Okay, so I will summarize the today's class. So first we seen diode compensation techniques. So these are three types. One is diode compensation techniques. Second one is thermistor compensation technique. Third one is transistor combination. So first one is diode compensation technique. So what do you mean by diode compensation technique? So diode is connected across base and emitter terminal. If temperature is increases, IC naught is increases. Similarly, at the same time, I naught of diode is also increased. I naught of diode is also increased means base current is base current is decreased. If base current is decreased means collector current is also decreased. How much percent increase due to temperature? That much percent decrease by IV. So that is called diode compensation. Next, we see thermistor. So thermistor is a negative temperature coefficient. That thermistor is connected across RE and R2. So if temperature is increases means resistance of thermistor is decreases. So if resistance of thermistor is decreases means VBE decrease. If VBE decrease means IB decrease. If IB decrease means IC decrease, because IC is equal to beta times IB. So IB is equal to I minus I naught. So that is thermistor. Next, last one is sensistor. In sensistor, device is connected between the collector resistance and R1. So sensistor is a positive temperature coefficient. If temperature increases, resistance of the sensistor is also increased. If temperature increases means sensistor resistance increase. Due to this reason, VBE voltage decreases. If VBE decreases means IB decrease. If IB decrease means IC decrease. How much percent we increase due to temperature, that much percent we decrease. That's why we call it as compensation. How much percent increase due to temperature, that much percent we have to decrease by using sensistor, so that we have to maintain output at a constant, or we have to maintain Q point constant. That is called sensistor compensation. Okay. Okay, thank you.